Hello, this is Dr. Weichel, and welcome to CS261 Fall of 2020, a short explanation of translating from one base to another. I just wanted to show you what a way to do something and the big picture behind some of the translations that we're asking you to do. And Dr. Lamb has done a really nice job of creating the videos, and we'll be going over a couple of things that he touched on there. But basically, we can think of this big picture as translating from base 10 or decimal, right, to some other base. Or we can think of it as going the other direction from some other base to decimal. And in the big picture, that's kind of the two scenarios that we have, because we're trying to get it into decimal or from decimal, which we're already familiar with. So there's two ways I'm going to show you this first thing. One I like to talk about as repeated decimal. Or I'm not sorry, not repeated decimal, but repeated division. And repeated division by the base. And in this class, we're going to be focusing primarily on bases 2, 8, and 16. So that's binary, octal, and hex. And then another way we can do this is we can think of the largest power of the base. And these are just what I like to call these two methods, and we'll show them to you here in a minute. Okay. And then from another base to decimal, we're going to use place value as our technique. And of course, place value plays a role in all of these techniques. But then after that, what I want to do is show you two shortcuts. And in particular, these shortcuts are how we go from octal back and forth between binary, and similarly with hex, where we go back and forth between binary. Okay, so let's get started with our first example here, which is doing repeated division by the base. Okay, so here's our example. We're going to do an example of repeated division, and we will take 25 base 10, and we're going to turn it into some number base 2, our binary. Okay, so what we'll do first is we'll take the base here, and we're going to divide it into the number. Okay, and so here we can see this will go 1, bring my 5 down, it'll go 2, I get 4, and then this is the remainder. The remainder's important to me, and what I'm going to be doing is doing this repetition until this number at the top equals 0, and then I'll be done. And so we'll keep doing this. 12 goes in 6 times. Now my remainder is 0. And I'm going to take that. It's going to come back down here. I'm going to divide it by 2 again. 6, I get 3. Again, my remainder is 0. And I'm going to take that quotient, come down here, divide again. 3, it goes in here 1. Now I have 1 remainder. Do this one more time. 2 goes into 1. Now I have my 0, right, and my remainder. So that means I'm done with that part. And now what I need to do is be looking at these remainders. And what I want to realize is that each one of these will come down, and the last remainder is the most significant bit, And I'm going to be careful to be taking my remainders, right, and not get any of my quotients, which is easy here because I know I have to have zeros and ones for my remainders. Okay. And now what I can see is that I would have 1, 0, 0, 1, 1, base 2. And so now this would be my x in the above explanation. So what I want to do is do a real gut check, okay, on my answer. And I can do that by translating back the other way, right, with place value and seeing that this is a 1 plus 2, 4, 8, which is 9, plus 16, which is 25. And so that's a good thing. So I can translate back. And that's more than just a gut check, right? But also another gut check can be, is it even? If it's even, it should end in 0. Well, no, what I want is odd. I want it to end in 1 in binary. Yep, so that one's good. And my other gut check can be, are there any numbers in here that are equal to or greater than the base? So do I have a digit that is greater than or equal to the base? And no, I don't. So that one's good too. All right, so that is our example of repeated division. So now remember what we're going to do is go back here to our big picture. We're going to try doing that same thing with the largest power divided by the base. Okay, so here is a largest power example. And for that, what I'm going to do again is do this 25 base 10, and I'm going to put it into some number base 2. We've already seen it, right? But what I need to do to do my largest power is I need to think of all of my powers of the base. Okay, so don't forget 1. That's really important. Any number to the power of 0 is 1. So we want to look at 1, and then multiply it again, right? 2, 4, 8, and each one I'm just multiplying again by the base, different powers by the base, and so I'm just multiplying each one by 2, 16, and then I'm going to go to 32, and now that I'm bigger than my number, I'm good. So what I want to do is I want to be able to say, what do I need? I'm going to start with the largest power. I need, in order to get 16, in order to get 25, I'm first going to take 16. So I'll take 16, and subtracting 25 from that, I get 9. So now I need 9, so I can take 8. Okay, and so 9 subtracting from 8 is 1, and I have 1 left. So I do not want any 4s, I do not want any 2s, I just want the 1. So now I have 0 there. So what I need to know now is in my bases, remember I have 2 to the 0, 2 squared, 2 cubed, 2 to the 4th, and I just have a 16, so I'm good there. So I skipped, you will see I skipped 2 to the 1. That's one of the common mistakes there, right? So 0, 1, 2, 3, 4. So what I want is 2 to the 1, 1. I don't want any of these, and then I want a 1 in each of these. And so again, here is my number base 2. So this is really mostly good. I can do my same gut checks and everything as I did on my other one, but really this method is just good for small numbers. At least from my perspective, that's where they're most useful. Okay, so let's now look at some other base. Now what we want to do is we want to be able to go from some other base to decimal. Well, to do that, I make use of the place value, kind of like we saw up here. So let's do an example of 1, 2, 5, base 8 to some number base 10. Okay, So if we do this, we have to put each number in its place. 5, right, is going to be 5 times 2 to the 0, or I'm trying to do binary again, but we said base 8 times 8 to the 0, which is going to equal 5, right? And then I have a 2 and I have a 1, so 2 is going to be 2 times 8 to the 1, and 1 will be 1 times 8 squared, and so this is going to equal 8, and this is going to equal 8 times 8 is 64,